Just copy this mac. Huh? नहीं नहीं आ रहा है. You just copy this one. Yeah, I'll make it. Look at this macro and function. Macro is pre-processed, function is compiled. No type checking is done in macro, type checking is done in function. Type checking is done using function. Okay, what is type checking? More you will can see in SDT, syntax directed translation. So if you are trying to do some operation between two variables of different data types. Example, A and B are the two different variables, and A is of integer data type and B is of a float number. Then if you are trying to do some operation between A and B which are of two different data types, then it is a type checking error, because you are trying to do some operation between two different data types. Okay. Now, because when you are trying to add integer and float, the result may give you a different invalid result. Example, 2 plus 3.5. If I add 2 and 3.5, then result is not equal to 5. It should be 5.5. It should be 5.5. So this will be this comes under type checking, and this will we will see more detail in SDT chapter, that is fourth chapter. Okay, so using macro type checking is not done, and using function type checking will be done. Speed of execution using macro is faster, speed of execution by function is lower. Before compilation pre-processing is done, and pre-processing macro is part of pre-processing. Okay, before compilation macro name is replaced by macro value. During a function call, a transfer of control takes place. A transfer of control takes place. A transfer of control takes place. And macros are macro is useful when a small code is repeated many times, and function is useful when a large code is repeated many times. And macro cannot check compile time errors, function can check compile time errors. So you just copy this, I'll give you some time. Okay. Okay, done. So this is about pre-processing, and we have done compilation also, we have done assembling also. Okay, I go up. So this is the what we are doing now. Language processing system, pre-processing is completed, compilation is completed, assembly is completed. Now link editor. Link editor. Already we have discussed in the starting of pre-processing. If a program is too big, it may be divided into small pieces. Okay, and they will be stored in different files. And each small program we call it as a module. Okay, so at the time of execution, as all these modules are of a single program, as all these some small programs are of a big program, so all these modules has to be linked as a single module at the time of compilation, at the time of execution. All these modules has to be linked as a single module. This will be done by link editor. The name itself tell you the meaning. The link editor links all the modules as a single module. Link editor. If the program is very big, it may be divided into small programs, and each program we call as a modules, and at the time of execution all these modules has to be linked as a single module, and this will be done by link editor. The link editor links all the modules as a single module. Okay, this is called link editor. And moreover, a high level language program may have some built-in libraries. I repeat, high level language program have some built-in libraries and header files. Built-in libraries and header files. A source program may contain some built-in functions, some library functions whose definitions are stored in built-in libraries. Example, you are writing a program, and in the program you have used printf, scanf, get character, like this. Okay, f close, f open. These are the built-in functions or library functions. These library functions whose definitions are stored in built-in libraries. So the linker links all these functions to their libraries. If the definition of a library function is not found in library, then it will throw an error. I repeat, high level language program will have some built-in libraries and header files. Suppose a source program may contain some library functions, and the definitions of those functions will be stored in built-in libraries. So the linker links these functions to their definitions, and if the corresponding definition is not found in the library, then it will throw an error. Okay, simple. The linker links all the modules as a single module, and the linker links the definition of a standard function with the definition in the library. Okay, and one more thing, the link editor also resolves the external references. The link editor also resolves the external references. What is this external reference? Okay, these are the small programs. Okay, are stored in different files. If a code, this is in one file, if a code in one file refers a location in another file, this is called as external reference. These external reference also resolved by link editor. Okay, simple. So take the notes. Okay. Now take the notes. Link editor. Link editor. If the program is too large, if the program is too large, if the program is too large, it may be divided into, already I have explained this in the case of preprocessor. I have dictated this. Again I am dictating because it's if the program is too large, it may be divided into small programs, within brackets modules, close the bracket. I repeat, if the program is too large, it may be divided into small programs and will be stored in different files. At the time of execution, all these modules must be linked as a single module. This will be done by link editor. Okay? Clear? Shall I go forward? Okay, continue in the next line. If the program is too large, it may be divided into small programs and will be stored in different files. At the time of execution, all these modules must be linked as a single module, and this will be done by link editor. Linker or link editor, both are the same name. Next line. The high level language programs have some built-in libraries and header files full stop. The source program sorry guys, actually I am not feeling well from last 2-3 days. Okay, so voice may be not clear and sorry. Okay, I repeat, the high level language programs have some built-in libraries and header files full stop. The source program may contain some library functions. The source program may contain some library functions whose definitions are stored in built-in libraries. The source program may contain some library functions whose definitions are stored in built-in libraries. Full stop. The linker links these functions. The linker links these functions to the built-in libraries. The linker links these functions to the built-in libraries. Full stop. Continue. In case the built-in libraries are not found, it informs to the compiler. In case the built-in libraries are not found, it informs to the compiler, and compiler then generates the error. In case the built-in libraries are not found, it informs to the compiler, and the compiler then generates the error. Okay. Next point. The link editor, or you can say linker. The linker also resolves the external references. Also resolves the external references. Also resolves the external references. Full stop. Continue. If a code in one file refers a location in another file, is called as external reference. Okay, next. Loader. The last part, loader. This one. So we have done the linking. Now loader. Okay, so till the linking part, the program resides at the time of pre-processing, compilation, assembling, linking. The program resides in secondary memory. That is, you can say disk. So at the time of running or execution of the program, it has to be bring to the main memory. So it is the part of loader. The loader loads the executable program. In main memory and initiates the process of execution. By transferring the control to the starting of the executable program. Simple. The loader loads the executable program from secondary memory to main memory, and it initiates the execution. It initiates the execution of the program by transferring the control to the starting of the execution of the program. It's simple. Okay. Now, what are the functions of loader? Functions of loader. allocation, relocation, linking, actually linking will be done by link editor. Some kind of loaders will be there, relocatable loader example. The relocatable loader will do the linking. So linking, in some textbooks you will find the functions of the loader: allocation, relocation and loading. Only these three. Okay, but you will not find the linking. Okay, and somewhere you will find allocation, relocation, linking and loading. So linking is an optional if it is not done by link editor. So some kind of loaders are there, example relocatable loader and dynamic loader, they will do the linking also. So linking, loading, assembling, itself it is a vast subject, huge subject. So it is not necessary that much in detail. Okay, so I will tell you what is allocation and relocation and linking. Already you know what is linking and loading. Okay, allocation means whatever the space required for a program to store in the main memory, that much of space will be reserved, allocated by the loader. So allocation, first it allocates. So this much of space is required. That much space will be allocated in the main memory. That comes under allocation. Okay. Now relocation. There are some address dependent locations in the program. Such address dependent constant must be adjusted according to the allocated space. Or simply I'll tell you, okay, this is the main memory. This is the main memory. And suppose this is address 0, okay, 0 and 1, 2, so suppose this is 0 to 1000 and here 1001, like this we have, okay. And we have a program, and it must be stored from address 0 to 500, okay. Suppose this is the main memory. In the main memory, suppose these are the addresses. In 0 to 1000, already it is occupied by some program. Okay, some other program. And this is the present program which has to be loaded from address 0 to 500. But 0 to 500 is not available. It is already occupied. Then what is happened? Relocation. So it is like mapping from virtual address space to physical address space. Relocation is a way of mapping from virtual address space to real address space, actual address space. So as 0 to 1000 it is already occupied. So what is happened? So from 1001 to it will occupied by some 1000, okay, 1500 some, okay, like this. Do you understand? So reallocation, whatever space is not available, the assigned space is not available, then this program will be reallocated in some other place. That is comes under relocation. Allocation means whatever the space required, that much of space will be allocated. Relocation means if the specified or already defined address is not available, then it will be reallocated some other place. And linking, you know what is linking. And loading means finally the instructions and data and subprograms of all these executable program will be finally placed in that main memory. Thus the program is ready for execution. Okay, so loading means load the program from secondary memory to main memory, and it initiates the program it initiates the program for execution by transferring the control to the starting of the instruction. Then the functions of the loader are allocation, it allocates the space; relocation, it is the way of mapping from virtual address space to physical address space; and linking, some loaders will also perform the linking. Linking means linking all the different modules into single module. It is optional, it is not done by all every time. And loading means finally it loads the executable program, instructions, data, everything into the allocated space in the main memory. Okay, this comes under the functions of the loader. This is simply about language processing system. Okay, if you have any doubts, you can ask me. So meanwhile, I'll dictate this loading. Okay, any doubts regarding the functions? So if you have sometimes already some of you have already seen this one. So this is a linking is an optional. Of course, this is a function of loader also. So linking can be done by loader also. Okay, so allocation, relocation, linking, and loading. Take loading. Loader is a software. Take the loader. Take the loader heading loader. Take the loader. Loader is a software. Loader is a software which does the job of loading. Which does the job of loading the program. Loader is a software which does the job of loading the program from secondary memory into main memory, from secondary memory into I repeat, loader is a software. Loader is a software which does the job of loading the program. Which does the job of loading the program from secondary memory. From secondary memory into main memory. See, I am dictating very slowly, even though somebody is asking us dictate slowly. So in this case, we cannot complete in time. So still, do you feel that I am dictating very fast? Please reply for my question. If you are feeling that I am still dictating fast, so I will go more slow. I'll go more slow in dictating. Okay, continue. Loader is a software which does the job of loading the program from secondary memory into main memory into main memory and initiates the process of execution initiates the process of execution by transferring the control Shivam Kumar, please make it so fast because almost 99% people are following my speed. So some of your friends are saying it is already too slow, but you are saying that it is too fast. So please, okay, because I have to finish in time. I know that this is very slow. Even you are asking to go more slow. No worry, boss, because this is the first class and theoretical. Most of the class, today's class is theory only. From next, so day by day there will not be more theory. And no need to dictate more also. You can go for running notes, and wherever it is required, the main points, definitely I will dictate slowly. Okay, please cooperate, Shivam. Okay, I repeat, loader is a software which does the job of loading the program from secondary memory into main memory and initiate the process of execution by transferring the control of execution to the starting of the executable program. Okay, from secondary memory into main memory and initiates the process of execution by transferring the control of execution to the starting of the executable program. Okay, now the functions of loader. Take functions of loader. Take first one, allocation. You write here, it allocates the required space. It allocates the so recorded session will be available to you. If you have attended late, if you miss some points, you can watch them. So I repeat, allocation. Allocate the space. It allocates the required space. I repeat, it allocates the required space in main memory. It allocates the required space in main memory where the object program where the object program would be loaded, for execution. Next, relocation. There are, take the second one, relocation. There are some address dependent locations. There are some address dependent locations in the program. Such address constant must be adjusted adjusted. I repeat, there are some address dependent locations in the program. Such address constants must be adjusted according to the allocated space. Full stop. Continue. Relocation modifies the object program so that it can be loaded at an address So relocation modifies the object program so that it can be loaded at an address different from the location originally specified. It is constant, not constraints. I repeat, guys, there are some address dependent locations in the program. Such address constants CONSTANTS must be adjusted according to the allocated space. This is done by loader. Next, relocation modifies the object program so that it can be loaded at an address different from the location originally specified. Relocation modifies the object program so that it can be loaded at an address. I told you now, here this part. It can be loaded an address different from the location originally specified. Okay, continue. Relocation is the way WAY. Relocation is the way to mapping from virtual address space, virtual address space to physical address space. Virtual address space to physical address space. Okay, so relocation can be of two types: static relocation. It is done during the loading of the program. Dynamic relocation This will be done at the execution of the program. So relocation can be done in two types. Static relocation means during the loading of the program, and dynamic relocation means at the time of execution of the program. Okay, take. It is of two types. Static relocation. So if you are following my notes and see, just wait for some time. You can see whether you are able to do the questions or not. So today we have not done even 3% or 2% of the subject. Okay, we are in the starting only. So let me finish the first two chapters. Okay, whatever the questions given in the workbook, out of them maybe one or two questions I do in the class, and all the questions will be different in the workbook. So you do all those questions and then you see the video solutions. You will know whether you are able to do these questions or not, whether really my class is helping you or not. Okay, so first of all you just follow the question class. Okay, now static relocation. Take static relocation. It is performed before or during the loading of the program into memory. Next, second one, dynamic relocation. It is performed at runtime. Okay, next. So this is done, relocation is done, linking already done. So linking is optional. Some kind of loaders will perform linking. Example, relocatable loader. Okay, example, this is relocatable loader. There are different types of loaders. Okay, all those we don't require all of them. Okay, relocatable loader, example for which linking will be done by it. Okay, and loading. Now take the loading. Take the heading loading. It finally loads the all machine instructions and data of corresponding programs data of corresponding programs and subroutines into the main memory. Thus the program is now ready for execution. Okay, so this is about functions of loader and the definition of loader. Okay, so we have finished the language processing system. So till now we have completed the language translators and language processing system, two concepts only. Okay, so the workbook I ask the management to the concerned team, the technical team to upload as soon as possible. So most probably by tomorrow or day after tomorrow I'll make it done, okay? And I'll tell you, after first two topics, I have told you in the starting of the class, after the first two topics, that is after finishing the lexical analysis, you can do the workbook. And even after finishing the first topic, I'll tell you, before starting the second topic also, some of the questions you can solve from the workbook, okay? Now, so any doubts? That's all about this second concept. We have done two topics. One is language translator and the next one is language processing system. So now, phases of compiler. Before going to the phases of compiler, I will give you the different types of compilers. Then I will go to phases of compiler. After the phase of compiler, then again I'll tell you the types of compiler. Sir, what is types of compiler before and after? Okay. So before phase of compiler, the classification of compiler, what are, I'll tell you. Then phase of compiler, then types of compiler. So that and this, what the difference you will understand once I complete the concept. Okay. Now, types of compilers. Somebody has already asked about this in the starting. Some student has asked me what is cross compiler. Okay. So that time I didn't answer his that question, for that question. Okay, because you will see now. Types of compilers. Native compiler. Native compiler. Actually, what is compiler? It takes the source code and produce the target code. Yes or no? So, compiler takes the source code, Suppose this compiler is running on machine A. Compiler is running on machine A. Okay, machine A. So compiler takes the source code and produces the target code. And whatever this target code produced by this native compiler, that target code also runs on same machine. Means the native compiler is a compiler which produces the target code that runs on same machine which the native compiler is running on. Do you understand? Compiler takes the source code and put the target code. So wherever this compiler is running on, for that same machine only the target code will be produced. Whereas next one, this is native compiler. And second one, cross compiler. What is cross compiler? Cross compiler will runs on machine A. Suppose it is running on machine A, and whatever the target is code produced by cross compiler, that target code will runs on a different machine. Native compiler is produced for the same machine. Cross compiler produce the output for different machine. That is okay. Okay, guys. I'll open the. So take the notes. I will change the page. It is not. So take native compiler. Take the types of compiler. First, native compiler. Native compiler. Native compiler. It is a compiler. It is a compiler which is used to convert I repeat guys, native compiler. It is a compiler which is used to convert convert a source code into a target code for the same machine which it runs, which WHSH. I repeat, WHSH. For the same machine which WHSH, which it runs, RUNS. Okay, so you can take this. Diagram. Okay, copied. Native compiler. Copied guys. Make it fast. We are going too slow. Okay. Next, cross compiler. Second one, cross compiler. So already I have explained this one. Cross compiler any compiler takes the source code and produce the target code. Cross compiler takes the source code and produces the target code. So while I am writing this one, you can copy simultaneously. I need not to say you copy this. Okay. So compiler take the source code and produce the target code. Okay. And what is cross compiler? Suppose the compiler is running on machine A. Okay. Suppose it is running on Windows and it produces a target code which runs on a different machine. So let it be Unix. Okay. So it runs on one machine. The cross compiler is a compiler which runs on one machine and produces the target code which runs on a different machine. That it is running on machine A and it will run on machine B. It is cross compiler. Take the cross compiler. Take the notes. It is a compiler. Take heading cross compiler. It is a compiler which runs on one machine and produces the target code for another machine. Okay. Next, incremental compiler. Incremental compiler. So what is compiler? It takes the source code and produce the target code. So while execution of the program, if any errors are there, all those errors will be produced. So we will resolve one by one, and again we execute. So whenever we execute, the compiler executes the total program every time from top to bottom. Okay, first we wrote a program, we got the 1000, out of 1000 lines we got the 250 errors. We resolve all of them, and whenever we re-execute, the compiler executes again from top to bottom. Now this time we got 100 errors, again we resolve, and again we re-execute. So every time whenever we are re-executing, the compiler executes from top to bottom. But incremental compiler is a compiler in which it executes the only modified source code. First of all, it executes initially from top to bottom total code, entire code it executes from top to bottom. Out of those, any errors are there, all of them will be presented to the user. If the user does any modifications in the program, only those modified program will be executed by the incremental compiler. The incremental compiler is a compiler which executes the only modified source code rather than whole source code. Got it? Next. Okay, take this definition, incremental compiler. Incremental compiler. So these examples you are not required, so just take the definitions enough. Incremental compiler. It is a compiler which performs the recompilation of it is a compiler which performs the recompilation of only modified source code recompilation of only modified source code rather than compiling the whole source code, whole source code. It is a compiler which performs the recompilation of only modified source code rather than compiling the whole source code. Okay, next load and go compiler. This is what it takes the source code and directly executes it. It takes the source code, conversion code to machine code, and directly executes. That means compilation, assembling, linking, loading, all will be part of this compiler. So it takes the source code and conversion, linking, loading, assembling, compiling, everything will be done by this one. Okay, simply take the source code and convert the machine code, convert the source code into machine code, and directly it executes. That means compilation, assembling, linking, loading will be done by this compilation only, this compiler only. Okay, take load and go compiler. load and go compiler. This compiler generates the machine code. This compiler generates GENERATES, generates the machine code and immediately executes it. Full stop. It means compilation, comma, assembling or assembly, compilation, comma, assembly, linking, comma, linking, or done by the load and go compiler. So if any errors are there in this execution, all those errors will be given. So if no errors are there, then compilation done, then assembling, then linking, then loading, then execution, all will be done by this load and go compiler. Okay, next. Source to source compiler. Actually, what is compiler? Which translates one language into another language. So source to source compiler is what? Source to source compiler. Hello dear students, you don't write S to S. What is S to S? Okay, so simply I wrote source to source. It means it takes high level language. Actually, what is compilation? What is compiler? It takes one language as input, high level language, and convert into another language. That will be low level language. So high level language to low level language. So here source to source compiler means it takes one language as input and produces another language as output into another high level language. So it takes one high level language into another high level language as output. Do you understand? So this is source to source compiler. Take the notes. Source to source compiler. This compiler converts one high level language. This compiler converts one high level language source code. Yeah, the load and go compiler will perform everything. So finally it will do the execution. Okay. Now come to source compiler. This compiler converts one high level language source code. I repeat, I am dictating source to source compiler. So take it. This compiler converts one high level language source code into another high level language source code. Another high level language source code. Okay. Next. Bytecode compiler. Compiler. Simple. This is bytecode compiler. It takes high level language as input, okay, and convert the output into bytecode. It takes the high level language as input and convert that high level language as bytecode. Convert the high level language as output. The output is bytecode. Okay, na? The bytecode compiler takes the high level language as input and convert into bytecode as output. Okay, next, I repeat, I'll give you notes, just listen. Next, just-in-time compiler. Just-in-time compiler. JIT, just-in-time compiler. What is this just-in-time compiler? If you know Java, Java is both compiler and interpreter. So because of JVM, Java Virtual Machine, it acts as an interpreter. So just-in-time compiler is a compiler which takes bytecode as input, and produces the machine code as output. Okay, actually Java is both compiler and interpreter. So JVM, so first compiler, the source code will be given to compiler, it will produce the target code, that is bytecode. That bytecode is given to JVM and JVM converted into machine code. So here I repeat, bytecode compiler is a compiler which takes the high level language as input and convert into bytecode as output. So what is the just-in-time compiler? Just-in-time compiler is take the bytecode as input and produce the machine code as output. Okay, so copy this, take the first, so I have completed till source to source compiler, na? So take bytecode compiler. Bytecode compiler. Modified source code matlab means the code which is done some changes. Whenever you do some changes, that is called modified source code. Modification. These are general common words. Modification, changes. Okay, bytecode compiler. Take the heading bytecode compiler. It converts high level language source code. It converts high level language source code into bytecode. Okay, into bytecode. You can copy that if you want. Next one, JIT compiler, just-in-time compiler. JIT compiler. It converts bytecode into machine code. It converts bytecode into machine code. It converts bytecode into machine code. So these are the types of compiler. So as of now, till now, no question is given based on these types of compiler till now in the GATE examination. But even though I told you the basic definitions, okay. Now one more is there, decompiler. What is compiler actually? Compiler take the source code and it convert into machine code. What is decompiler? Reverse. It takes the machine code, it takes the machine code, it takes the machine code, it takes the machine code as input, and convert this into high level language. Reverse. Machine code as input and high level language as output. That is decompiler. So this is what is cross compiler, native compiler, source to source compiler, and incremental compiler, just in time compiler, bytecode compiler, load and go compiler. But actually based on the division of phases, the next concept, phases of compiler, that part I don't do now, so I'll leave you now. So tomorrow I will tell you the phases of compiler. Phases of compiler. It is important topic, and if any of you are having this subject in your semester, so you may get, there are a lot of chances you may get the question that like explain the phases of compiler. Explain the phases of compiler. So whatever I do in the class, that is more sufficient. So you will get the complete 100% marks in your semester if you have, anybody have. So that is anyway important for us. So tomorrow I start the class with the phases of compiler: lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization and code generation. What are these all phases? With one good example I will explain you clearly. Then based on the phases of compiler, how the compiler will be divided. So mainly compiler will be divided into two types. One is single pass compiler and the other one is multi-pass compiler. Okay, you might have heard about this, single pass and multi-pass, or you can say narrow compiler, wider compiler. So what is the single pass compiler and multi-pass compiler? Before that, first of all, I will tell you what are the different phases of compiler. Based on that, I will go for single pass and multi-pass. And what is the differences between this single pass and multi-pass, I will explain you. And with that, the first topic will be completed. Then you can go for workbook if you are interested. Or once I complete the lexical analysis second topic, then first chapter completely you can do. Okay. So that's all. Now I don't want to start this new topic. That is the next concept. The next concept, that is lexical, the phase of compiler, which we do tomorrow. Tomorrow the class timing is 9 a.m. to 6 p.m. So in between lunch break I will give you, and morning session also I'll give you small break, and afternoon session also I'll give you small break. In between morning and afternoon I'll give you lunch break. Okay. So tomorrow I will meet you at 9 o'clock, and tomorrow onwards the class will be more interesting. So mainly the theory part is completed, and tomorrow that is little but but it will be interesting. Okay. I hope tomorrow onwards it will be smooth. And so some of you have faced the problem with the dictation, and only first topic require the more dictation, and the second topic onwards it don't require that much of dictation. Okay. And thank you. So if you have any doubts you can ask me. The class is done. If anybody